Hello, I'm Julie Kiefer, and presenting with me today is Josh Saltz. We are students at the University of Nebraska, and last semester we participated in Dr. Wagner's data visualization class. In the class, we were asked to create a data visualization tool that was different than any other tool currently available for that type of business data. We were encouraged to use a metaphor to tell a story with the data. We used the metaphor of weather forecasts to explain staffing forecasts. Our group decided to tackle the issue around hospitals trying to manage their nursing staff. Currently, there is an enormous amount of information available to the hospital executives and managers, but it is difficult to come to clear and concise conclusions. Our tool allows them to quickly see what is happening at all the hospitals in their hospital system, as well as a more detailed view of each hospital unit. Therefore, they can assess the staffing situation in real time and proactively correct staffing shortages before there is an issue.
Thank you, Julie. The purpose of our main page is to give an overview of the entire Gemstone Healthcare System staffing situation. It lets you see the staffing fill rates, the current situation, forecasts, and factors that impact hospital population. The left panel presents the staffing numbers in a quick, easy-to-read format for the entire hospital system. This is similar to what you would see if you went to weather.com, but instead of temperature, humidity, dew point, and cloud cover, it displays the fill rates for registered nurses, licensed practical nurses, certified nursing assistants, and an overall fill rate for the hospital. The overall fill rate is an average of RN, LPN, and CNA fill rates. We assume that the hospital had 4 shifts throughout the day. The bottom section shows the fill rate forecast for each of those 4 shifts. The icons are determined by the shift's fill rates. The dividing line between sunny, partly cloudy, and stormy can be altered by the customer to suit their comfort levels and comply with state and federal staffing regulations. Patient census for a hospital drives how many nurses the hospital needs at a particular time. Some of the key factors that drive patient census are the flu index and allergy index, depending on the time of year. Now, moving to the far right panel. The solid line on the graph represents historical averages, and the dotted line represents the current year's trend. Both lines are plotted using data from the Center for Disease Control. If the dotted line is much higher than the historical average, decision makers may want to keep more nurses on hand to meet the increase in demand.
Okay, so in the center section of the main page, the radar map is a graphical projection of how the staffing situation is predicted to change over the 4 shifts during the day. This allows the user to see the data in motion, rather than static icons and percentages. Data in motion is much easier to comprehend and more engaging. The movement can be stopped or started by double-clicking on the graphic. The radar map now has been stopped at the 3 p.m. shift. There is a red front moving across the map indicating that there is an understaffing situation. For our data visualization tool, we have used red as understaffing, blue as overstaffing, and white indicating an appropriate staffing level. So this map can be clicked to start and stop to view the staffing situations in all of the 4 shifts. Then below the radar map are 3 icons labeled East, West, and South, denoting a hospital within Gemstone Healthcare. Clicking on one of them drills down to that specific hospital and displays information about it. So this brings us to a hospital-specific view. To keep things consistent for users, the left panel displays information in the same format as the main page. The difference is that the data is specific to a particular hospital rather than the entire Gemstone Healthcare System.
As you may have noticed, the middle and right panels have changed considerably from the main page. Instead of having a weather system move across a single point in a traditional weather map view, we broke down the hospital schematically. The schematic is not specific to that hospital, but allows us to show changing conditions inside each unit in the hospital. Also, having a standardized layout for a hospital allows a user to determine what types of unit a hospital has and locate those units quickly. The colors represent the same types of staffing situations as our previous radar map: red understaffed, blue overstaffed, and white is acceptable. As before, the map also rotates through each of the 4 shifts in a day and can be stopped or started by double-clicking the graphic. Being able to determine a hospital staffing situation is one thing, but being able to correct the staffing issue is an entirely different issue. Our visualization enables the user to do both. You may have noticed that our right panel is currently blank. It remains blank until a unit is selected. A unit can be selected by clicking one of the icons at the bottom of the screen. After a unit is selected, the upper right panel displays the current staffing situation for that unit. This is displayed as a reference point for the user. The bottom panel now allows us to correct a staffing problem if there is one. To correct staffing issues, we have an Add Person button and a Remove Person button and an On-Call pool. For our example, we will assume the ICU is overstaffed. To correct this situation, we click the Remove Person button. This takes one person out of the ICU and puts them into the on-call pool. Removing one, this is indicated by a lightening of the shade of blue. If too many people are removed, the color changes from blue to red and darkens according to the severity of the understaffing. This feature allows the user to correct staffing problems versus simply displaying them. We believe that the impact of displaying data in a fun and easy way engages the user and ensures an enjoyable and productive experience. This concludes the explanation for our data visualization.